Welcome to Talks at Google in Cambridge, Massachusetts. This morning I'm excited to introduce Nick Montfort, Associate Professor of Digital Media at the Massachusetts Institute of Technology. There he directs the Trope Tank Research Lab studying literary generators and computational art. For over a decade he served on the board of the Electronic Literature Organization, and he's principal of the naming firm NomNim. Today Nick will read from his latest book, Shebang. Shebang presents computer-generated poems alongside their corresponding source code. His other works include Twisty Little Passages, a survey of interactive fiction, and Tenprint, a 10-author collaboration on creative computing. Please welcome Nick Montfort.
Thanks very much. Form intends intense verse, crease to tense form, tense vent, verse tone, verse form, crease form, vent tends to crease, to tens form, form, vent, form, crease, tone, verse, tense. Crease, vent, vent, tens inverse tone into verse form. Verse, verse, form, tone, tense in. Tense, vent, crease. Verse, tone, tens, verse, tens, tens, tense, verse, crease, form. Tone, vent into tens. To crease, vent to crease. Vent, verse, verse, vent to crease, vent. Form, tens, vent, crease, tense, form, tens, crease, in tone. To tone. Verse, vent, crease, in tens, vent. Vent to tense, in form, crease, vent, crease, form. To tens, tone. Verse, form, vent, tens, tens, to. The work I have been reading, Round, is a very simple program and poem that's available on the web at round.newbinarypress.com, and as with all my creative digital work, also available on my site, nickim.com. It displays the digits of pi, but instead of using the numerals 0 through 9, the program presents strings of text that correspond to each digit. 8 of them are words that can stand alone. 1 is the prefix in, and 1 is a line break, which shapes the poem into lines of irregular length. So, since 3 is represented by form, 1 by in, 4 by tens, 1 by in, 5 by tense, and 9 by verse, the first digits of pi, 3, 1, 4, 1, 5, 9, are represented by form in tens in tense verse. Round is a computational poem that is both non-interactive and deterministic. It is computational in that computation is an essential aspect of the work. Non-interactive because there's no input accepted as the program runs, and deterministic because the text produced should be the same each time on any properly functioning computer. The poem is also infinite or boundless. There's no final line or internally specified condition that will cause it to stop. Round does not contain any list of digits of pi. It computes each digit using a spigot algorithm. If it did store as data 1,000 digits or 10,000 or any finite number, the program would be unable to continue representing the digits of pi after that point. Instead, Round computes pi. As the program runs, the production of text slows down as more and more steps are necessary to determine the next digit. You may be able to see that in this Python instance of the program. The multitasking computer running the program will also begin to run other processes more slowly and will physically heat up. The computer's fan will work harder as the processor labors to complete these computations. Verse, tense, tense. Tense, vent, crease, crease, form, intone, crease, tense, form, tense, verse, tens. Vent, increase, vent, tens, vent, in, tone, tens, tense. Crease, vent, tens, in. Crease, tone. Inverse, form, vent, tense, crease, in. Tense, 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 verse. To tens, tens, to crease, crease, verse, tens, vent, verse, tense, tens, verse, form. Of course, this is probably the audience I need to tell least about the materiality of computing, the labor that might be involved in scanning in books, the physical and material computation that's required to do large amounts of symbol manipulation, data retrieval, and delivery. But this is a way of looking at this, and for people whose experience of computing is maybe more ethereal, and for people who believe that digital poetry and the work that we do with text on the computer is actually immaterial, this is something of an answer to that, showing that there is something going on in terms of computation, something almost mechanical, that is a laborious process. And it also questions various ideas of the need to combine things at random in a digital poem, for instance, which is not literally done in this case, although obviously it's a quite unpredictable sequence unless you know that it's the digits of pi that are being represented. So I wrote this next poem, Taroko Gorge, in January 2009 in about one day at Taiwan's Taroko Gorge National Park. It's actually a pretty conventional poem compared to a lot of the things that I write, or a lot of the things that my programs output. It's meant to be a generator of nature poetry. I figured that if other people had gone to beautiful natural places, as stereotypically is the case, and they've written poems about them, why couldn't I go to a beautiful natural place and write a poetry generator about this place? This one also is a boundless poem, running until it's interrupted, but as I think you can see, it's not formless. Each of the longer strophes begins and ends with a path line of a certain type, representing motion along a path in Taroko Gorge Park. And in between, there are 0 more view lines representing stopping to look at the scenery at a designated viewing spot. And then these individual lines that appear in between the longer strophes are what I call cave lines, representing the tunnels that Chiang Kai-shek had his nationalist army carve through the mountains when they came to Taiwan. Stones pace the ripplings, shapes sweep the flows. Translate the objective driven. Layer paces the coves, coves hold. Mists trail the stones. Shade the encompassing rough. Brow ranges the flows. The crags hold. Shapes rest. Layer ranges the stone. Shade the encompassing rough, sinuous, straight. Now, I was pleased to do this exercise and to undertake this nature poetry generator. One of the things that you see in the book is that, as with all of the outputs of these systems, they're presented after the code for the program itself. This is in part just a reference back to the days of basic programming in the 70s and 80s, when one would find books and magazines that presented code for people to type in. They gave some sample output so you can make sure that what you were inputting, was really what it was supposed to be. And they gave an attitude of openness toward computing. And of course, on the web, you can just view source and examine how things are done in JavaScript in the same way. This is what Scott Retberg, a friend and collaborator of mine, did, and without telling me about it, he also made his own work out of Taroko Gorge, a piece called Tokyo Garage, and where I wrote a poem about a beautiful natural place that I'd actually visited myself. What Scott did was to write a poem about an urban place in the East that he had never been to, supplied only by his feverish imagination of what it would be like to be in Tokyo and all the stereotypes that we have in the West. Translator funds the libation. Dealers reverse. Protagonist suffers the libation. Endure the electrical banal blinking. Teenager confuses the kids. Earthquakes reverse. Talk show host orients the sushi joints. Harmonize the abbreviated. Well, suffice it to say that other people started doing this as well. J.R. Carpenter created this piece, Gorge, a modified version of Taroko Gorge, which describes another endless process, that of gluttony and endless consumption, and the disgusting and yet unstoppable processes thereof. J.R. did some additional pieces. One of these that I certainly want to point out is Andrew Plotkin's piece, in which he took all the remixes that happened up to this point, showed them remixed with themselves and with other remixes, and also displayed the code that corresponded to what was being printed at different times. So this is really a tour de force, and he doesn't actually, only a small amount of my original code obviously is part of this. It's a different type of takeoff. This is a remix of Eric Snodgrass's Yoko Engorged, which is about Yoko Ono and her performance art. And this is a remix of Fred and George and Toy Garbage down here. And then, some people simply created work that many people use the particular form that I created of these path lines, view lines, and cave lines. But some people actually discarded that. They just sort of took the code as a starting point for making their own sort of project with their own form. And Sonny Ray Tempest did that, creating these quatrains in his piece Camel Tail that are a patchwork of all of the lyrics from Metallica's 9 major studio albums. You can see here the production is something of quite a different sort, but I think it rhetorically gets across the point that that metal is more of a texture than a narrative or a story, right? It's you can take these lines and put them together at random, and you still sort of feel what you're supposed to feel, when you're listening to the song. Much too young to focus. No more anger, master. Yeah, pretty much, that could be a lyric. All right. So to end this most coherent section of my reading, I'll present some of the output from my first Ruby program. I was commissioned to write something for the book, The Ill-Tempered Rubyist, which is sort of code poems, and it had this title, and I thought, well, I'll need to see what I can do, actually in Ruby. So the program is built with text from Edward Fitzgerald's translation of the Rubaiyat of Omar Khayyam. And before I read the output, I'll read you the program itself, not enunciating the punctuation marks well enough for you to type it in, but you can see the book for that. And I think you'll get some sense of what animates it, even if you aren't particularly familiar with Ruby, as in fact, I'm not. Rubaiyat, shebang user ben Ruby. A phrases equal, aureate, alternate, along with, argument, another, absolute, alchemist, arrest the, an empty, a ruby, a little, 1,000, a book of, and piece to, a jug of, a loaf of, a distant, and out of, and lose your, a moments amid the, are all but, awoke from, and by the, all this of, a shallow, as much as springs the. B phrases equal, beneath the, before the, but still the, beside the, beloved, better be, by logic, blaspheme the, before us, beset the. Rhymes equal, stare, there, care, dare, snare, bear, air, hair, tear, nair. Non-rhymes equal, sun, stars, shaft, cup, bird, wing, winds, dust, knot, lamp, lip, dusk, balm, bowl, song. 6 times, endings equal, rhymes.sample 3. Endings.insert 2, non-rhymes.sample. Beginnings equal A phrases.sample 3. Beginnings.insert 2, B phrases.sample. 0 up to 3. I puts beginning I plus space plus endings I. Puts. A little bare are all but there, by logic shaft an empty stare, absolute there amid the stare, blaspheme the dusk, argument bare, and by the there an empty air, better be cup a distant hair, 1,000 stare, a moment's care, beloved cup arrest the snare. Awoke From tear, a jug of nair, better be cup, a distant stare. 1,000 tear, a jug of snare, beset the balm, a moment's air. And I'll read you the version that is printed in the book. Amid the care, and lose your air, better be wing another there, a distant care, a loaf of nair, by logic dust, and by the dare. A ruby there, an empty air, blaspheme the cup, and out of hair. And lose your bear, absolute dare, before us wing argument care. As springs the care amid the tear, before us stars another snare, along with tear and peace to dare, beside the cup, argument, care. Now in the book, you can see a few conceptual poems that refer to some earlier digital work. One that is pretty simple in form is based on the permutation poems of Brian Geisen, which Ian Somerville implemented computationally. And so I Am That I Am is a sort of homage to that simply displays all the permutations of the 5 full vowels. And there's also a piece based on a work of Claude Klossky's, which is the first M numbers in alphabetical order. So Claude Klossky did a piece in 1989, both in English and in French, where he presented the first 1,000 numbers in alphabetical order. And of course, they're alphabetized differently in French and English when they're spelled out. And so he showed these, and to me, it was a very interesting display of the arbitrariness of our various systems of language, when it comes up against number. So I did a version called the first M numbers in alphabetical order, and it generates and alphabetizes the first 1,000 Roman numerals. So I'll show you a little of the Concrete Perl series of programs. There was one of these actually that I showed early on before I got started, and that was letterform terrain. And this is a piece that it uses a Perl special variable that has a value equal to 60. We actually did I worked with a Russian translator, and we did a transliteration to Cyrillic of this piece, letterform terrain, and we had a Russian title for it. And for one thing, the landscape is denser because there's more characters in the Cyrillic alphabet, but that value of 60 stays the same. So one of the possibilities, even at the letter level, for moving between languages and alphabets is to see how it is that the systems we use, Perl, ASCII, Unicode, come up against different human languages and how they work differently. I'll just show you the code for that itself, which is that. This is a 32 character Perl program, and I have a set of these. The Concrete Perl programs are all 32 characters long. And then what I'll show after, I'll show a few examples of PPG 256, that series of 256 character Perl programs. I showed some of these to an actual professional Perl programmer, not someone silly like me who's playing around with Perl to do these sorts of things. And I showed actually one of the PPG 256 systems, and this person was completely unimpressed by what the program did. But he looked at the program and said, redo? Because he'd actually never heard of that keyword. But it turns out that as far as I can tell, the most concise way to create a loop is to have a code block with redo at the end in Perl. So look at that. Even I can learn something about Perl, which probably shouldn't be learned. But so let me ask. We can make maybe the screen. We can do for the video full screen for this, and I'll show you alphabet expanding. So I find this mesmerizing. It's not at all a piece of video art. You have to start it or have someone start it for you, I think, to really get the effect of it. And of course, it helps to know the code that's animating it as well. These programs, these Concrete Pearl programs, are written for terminals or consoles of any geometry. So they're meant to work no matter what typography and what size of window or console you're using. This one here is simply increasing the amount of spaces between the alphabet, which it's printing repeatedly. And it's doing that very, very slowly. And so that alphabet goes in and out of phase with the size of the terminal, producing these different types of effects. So another one of these is all the names of God, which is printing every one letter, and then every two letter, and then every three letter word, and so on. Until eventually, because it's trying to pre-compute them all in memory, it will crash. And if you've read Arthur C. Clarke's 9 Billion Names of God, you'll probably be glad that it does crash, since you know what the outcome might be of continuing. And the last one of these is actually a fairly simple one, but one that I think has a point. It's called ASCII hegemony. So when we translated this to Russian or transliterated it to Cyrillic, this one stayed the same because this is just all the printable characters in ASCII. And actually, early electronic literature work in Russian was done in ASCII because there was not support for the Cyrillic alphabet on the first computers that were popularly available there. And even as we continue with amazing projects like Unicode, there's still these questions of how different programming languages and different environments support different alphabets. So you can get Latin alphabet in Perl by saying A.Z, but you can't do that for Greek or Cyrillic or other alphabets. Of course, you can work around that, but your program isn't going to end up being 32 characters long in those cases. So I'll finish up this next section of the reading. There's probably two more little pieces here, but I'll finish up by reading just a few of the PPG 256 pieces. Let me show you what these look like. So here's the first of these, for instance. These are besides the comments here, I made this file so that it could be run on Windows. But the program itself is just the bottom three lines there. And it doesn't use, as with Concrete Pearl, of course, it doesn't use any external stores of data, doesn't do anything online. Everything that it produces is actually encoded, in that 256 character program. Of course, it uses the Perl programming language and all the capabilities that has and all the ways that animates computation. But everything has to be packed into that short program. And so for me, this is a challenge to try to explore things about Perl and also about poetry and language. How could I make a very concise program that would at least look like a poetry generator, would be read that way by someone who is, a sort of generous, willing viewer of the program. And so this is what I came up with. I'll tell a little bit about this before I read from it. So the first task I set myself was to generate a very, very large vocabulary. How could I create a large number of words? Well, there's well-known ways to do this. So in Claude Shannon's Mathematical Theory of Communication from 1948, right, he describes the process by which, through using conditional probabilities and increasing n, one might be able to generate text at random, including words at random. The problem with this is that if you want to use even just bigram probabilities, you have 26 letters and then there's 26 letters that could come after it. It's 276 letters, and so that's going to be a lot of conditional probabilities for 256 characters of code. They're probably not going to fit in there very easily, if at all. So I was trying to figure out a different way to do this, and the way I came up with was I tried a bunch of things, and I was getting maybe dictionary words like 3% of the time. It was very futile. And then I decided, okay, well, what if I just take the first 2 letters of common 4-letter words and the last 2 letters of common 4-letter words, and I'll just jam them together at random and see what happens. Well, as it happened, even without any fix-up, I was getting 60% dictionary words by doing that. It was pretty amazing. I had a chance to speak to a phonologist at MIT about this and to describe this process. And he said, oh, yeah, turns out for monosyllables, like the sort of initial and final diagrams are going to be pretty much independent. And so my first thought was, oh, well, he knew that already. That's too bad. And then I was like, well, he probably went to graduate school for like 7 years to learn that, and I was just playing around with a Perl program for a few hours. So maybe that's interesting. And maybe there's other things that I learned about this as well. So if you just produce a string of words, it's not that recognizable as a poem to most people. But if you shape them into lines and stanzas, it's starting to look more like a poem. And then I spent a good deal of those 256 characters producing these titles at the top of each of these, right? And just indenting by 1 space. So it turns out that makes things, at least to me, look considerably more like a poem. These framing elements and the overall shape of the poem are quite important to it. The car, tat to bide. The burr, hoke no tosh, toes on hose. Cack on bar, the pang, rawl on mosh, bat of deer. So I'll show you the second one of these. I tried to do some things quite differently here. I was satisfied with a small vocabulary. There's only 89 words this generates, including all the close class words, the ampersand. But I wanted to have a variable line length. I wanted to have a shape of a stanza. In fact, the line tends to become smaller, as you can see in the pans here, as this continues. I wanted to have variability of word length as well. And I was willing to sacrifice that large vocabulary to do this. So I get things like this in this poem. The kits, the pan, akin, a twin, of twit, twits fit, shill, span, the skill, sit and skit, to chin, a shin, a spill, to sit, fan, the grin, grit. The grins, twin and shill of spit, chill shills the grin, spin to spill, a kit, chill, twill. A solution to generating the indefinite article is to not produce any words that begin with vowels. So I never have to, or that begin with vowel sounds. So I never have to produce an. I only have to produce a. So there's a lot of things like that, which are not certainly general purpose solutions, but which give for me, an interesting engagement with language and understanding of the possible textures. So there's actually 7 of these, but I'll read a bit from the third, and then I'll move on to this final thing that I wanted to share with you. And this third one, I decided I'll get rid of the titles, and I'll try to look at compound words. How can I compound a list of 3-letter words that stand alone as words into new words? And how can I make something that seems like maybe the beginning of a narrative, not a full story, but something that suggests a situation, something that's suggesting narrativity? And this is what I came up with. One red man-ape, and the wax ape-ape, cut on, hip godbot, and the boy eel ran off. The wan man-hat and ape boy put out. One bot elf and one elf nun jam her. One god man and one red elf orc set on. The nun man and one fat orc bot hit us. One red hat orc and the ape boy put her. So that's PPG 256-3, and it's a third of 7 of these very, very concise Perl programs, which I think you get the sense I'm not trying to use to express things about my life or emotion, but I'm trying to use to explore language in a poetic way through the making of a poetry generator and the making of poetic language. In some ways, the same type of investigation that people are doing when they're doing linguistics or computational linguistics, but through a different non-scientific means, that is this poetic production. So I wanted to share with you a book that I just finished and just had printed. It's called Megawatt, and it's a book that there's some story behind it. The seventh of these PPG 256 programs is based on a passage from Samuel Beckett's second novel, Watt. And after doing this, I made a demo scene production called Nanowatt, which is a 3.5K VIC-20 program that generates 8K of Watt exactly in English, and then it goes on to generate 8K of Watt in French. These are certainly out of the ordinary endeavors, but the point of engaging with the novel in this way is to try to read it, to try to understand it through re-implementing it. So I'll show a little bit of. Here's the. So this is the book cover, and this is a little from the preface, and which is also the doc string. And Megawatt then is the third computational project I've undertaken to try to deal with Samuel Beckett's novel. This novel, I mean, it has some more or less ordinary language in it, but it also has these, really bizarre passages in which every combination of 3 or 4 different elements, will be described. It will be described, for instance, that Watt heard voices which, sometimes sang, cried, stated, or murmured, or that he felt calm and free and glad, but maybe not calm and free and glad, but at least calm and free, or free and glad, or and so on. And so what I've done is to re-implement these passages from Watt computationally. Right? I created programs that would write what Beckett wrote, and then I extended them so that they would say even more. So the 2.5 pages that are in Watt describing Mr. Nott's physical appearance occupy here more than the corresponding section in Megawatt occupies more than 200 pages. And I'll read you a little bit of that. With regard to the so important matter of Mr. Nott's physical appearance, Watt had unfortunately little or nothing to say. For one day, Mr. Nott would be thin, small, pale, dark, brown-eyed, ectomorphic, clean-shaven, and erect. And the next, thin, small, pale, dark, brown-eyed, ectomorphic, clean-shaven, and stooped. And the next, thin, small, pale, dark, brown-eyed, ectomorphic, clean-shaven, and leaning. And the next, thin, small, pale, dark, brown-eyed, ectomorphic, bearded, and erect. Okay, and so on for more than 200 pages. And at the end of this book is all of the code that's used to generate the main text of the book, 350-line Python program. And from a standpoint of reading from literary experience, it seems that we're confronted with things that, although in terms of the amount of time it takes to read them, we physically have the time in our lives to read something like this, but it's illegible due to not being created in a human way for reading. But we can still encounter it computationally, and so Megawatt is part of that project, and Shebang is another aspect of that project, not to confuse, not to puzzle people, but to show that computation is something that can engage with poetry and language in new sorts of ways. And of course, the focus is on these very simple programs, which for the most part can be used offline. There's only one part of Megawatt that even makes use of WordNet, because there's the dish that Mr. Nott eats that seems to contain every possible food in it. And so I use WordNet to enumerate that possibility. So that's some about the project of Shebang and this, this newly released book. And with that, I'll open it up to questions.
So does your code come with a license?
Yes.
Maybe not
So
just the
generally, all the code is ISC licensed. So it's all free software. When you find it online, it has this license. I have a note in Shebang saying that it's free software and where to find it online. But we didn't repeat the license for each one of these very short programs, many of which, I mean, we have a 32-character Perl program. It's a little onerous to include even a very short license in that case. It's also a question as to whether a 32-character Perl program can be copywritten. I mean, I'm not sure. The short phrases are not do not fall under copyright law. So it's not obvious to me whether those would be afforded copyright protection.
Well, then the follow-up question is: does your code contain expression?
Oh, I hope. Well, I hope not. Yes, because. Most of it is a very conceptual project. I mean, certainly Taroko Gorge is expressive of a type of experience, a type of feeling. It's one that can be continued, that doesn't have a particular end. It's an experience of nature. So there are aspects of expression in it, but to me, that's not the point. It is something that I'm using to investigate language, form, poetry, and other people can do other types of projects that are more focused on expression, but those are the things that that interest me particularly. Is really to be an investigator of language, which has such an amazing history and such a rich potential to connect and divide in various ways.
What about color? Have you ever played with terminal colors, like 256 color Xterm, for example?
I think probably just decorating things on the web is about the only thing that I've done along those lines. Yeah, with things like Concrete Perl, which are visual programs, I really tried to make them more or less generic to the color of text or the typography. So,
thanks.
All right.
So the generators you presented are all fairly minimal. Do you have any longer form works that aren't quite interactive fiction, but are somewhere between these minimalistic examples and normal Z-machine programs?
Yeah, so certainly the focus in Shebang is on these very short programs. I think that almost all of them fit on a single page. And some of them are much shorter. And it's probably, yeah, so Through the Park and Taroko Gorge go across 2 pages. They're quite brief. In part, my interest in these short programs is just that there's still enough to do in the very short amount of space, a very small amount of computation that's interesting, that I don't feel like moving on from that in many cases. It's also something where I can afford to more intensively go over this and understand more about it if I have something short. I have systems, I mean, a megawatt is 350 lines, which is getting to be longer. It's not a large-scale enterprise program. I do have the system CurveShip, which is a full interactive fiction system. And it's implemented in Python, and it does the basics of what systems like Inform, TADS, that line of work will implement. And plus, it also allows for narrative variation so that the same underlying events can be represented different ways. So that's a larger scale project, which I'm pleased with. But on the other hand, I've never really written I have demonstration programs that I've done in CurveShip, but I've never really written an original work in CurveShip that was an extensive original work. And I think it's possible that that's because I spent so much time working on the system itself and building all of this out. So the focus my focus has been on this smaller scale, but I think there's interesting possibilities for individual and collaborative authorship of sort of medium scale works. I mean, one of these pieces that is definitely larger, which is a collaboration of mine with Stephanie Strickland, is Sea and Spar Between. So this is a poetry generator we did in 2011. We published in 2011, and it's a conflation of Emily Dickinson's lexicon of her poems and of the lexicon of Moby Dick. And it's about 225 trillion stanzas that are arranged in this lattice. So you can go, there's coordinates, and you can go to them. It's actually a fixed text that you can go to, but it's sort of it's so large that it's meaningless to treat it that way. You might as well just open it up and look around and encounter it, the way we're doing now. And this is a larger scale project. I'd say sort of medium scale, and for a collaborative project that spans some time, it was pretty useful. Let's see here, to do something of this size. So you can go, if I go to 0, let's see, 0, 500, what's that? Listen now for Ulysses' sky, one air, one each, one play, paradise, spirit. So, and then I can go somewhere else. I'm just navigating here. If I go back to 1, 500, 0, 500 is what I was looking for. Oops, I have to type it right. I should get the same thing. Yeah. Listen now for Ulysses' sky. So this is an example of sort of a medium scale project. I mean, there's different things that come out. So this has actually been remixed the way that Taroko Gorge was once, that we know of. It's been translated to Polish, which is an amazing undertaking, and it's also been remixed to create a piece called House of Leaves of Grass, which is based on Mark Danielewski and Walt Whitman, and Mark Sample did that. So I think one of the things is that these very small scale pieces, they invite others to study and understand them, to manipulate them, to rework them, to create their own pieces based on them. So in that case, I mean, Taroko Gorge was, I think, extremely successful. If I'd made it, 10 times the size that it was, it fit on one. It's less than 66 lines long. It fits on one, sort of dot matrix printed page. And if I'd made it 10 times as big, nothing that you saw there along the right-hand side, all of those remixes and work, would have happened. So there's some significant benefits to doing smaller pieces, and I think that you shouldn't exceed the size of your concept in writing programs like this, poems like this, and this sort of code. But if you have something that is a bit more expansive, then it makes sense to have a larger project.
Thanks.
If there's no questions, I'll just offer some company names for anyone who would like them. All right. Thanks. Thank you.